Hey guys, you're watching Fitness Regiment, and I believe this is the 4th episode of Learning R. And in the last episode, we did some arithmetic operators and demonstrated some of the vectorization in R and some of the important arguments. So here we're just going to talk a little bit about the different mathematical functions. You can look these up, so it's not too important. We haven't really delved into anything important yet. These are just the basics. If you already know them, you can go ahead and skip to an episode that you don't know. So I'll try to make this fairly quick. So R obviously contains a really wide selection of mathematical functions. Some of them, for example, trigonometry has sine, cos, tan, and asine, acos, and atan. They're inverses. It's got logarithms, just log, exponents, which is just exp, so x, and then their variants such as log 1p, exponent m1. So for example, log 1p is log of 1 plus x, and x m1 is x x minus 1. So they're for very, very small values of x, basically. There's so many mathematical functions, there's really no point of me going over them. I'm just going to be showing some examples of what you can do. So I'm concatenating a function from 0, pi over 4, pi over 2, and pi. I think I forgot pi. And I just take the cosine of all of them. So pi is an inbuilt constant, of course. There's also Euler's formula. So here we take the exponent of pi to the power of 1 times the imaginary unit I plus 1. And we can also do factorials. So factorial 7 plus factorial 1 minus 71 to the power of 2. And that should give us 0. And there's also a choose function where you can go choose 5 and 0 to 5 using the colon operator. So you can also use to compare integer values, you can use double equal sign. You do not use the single equal sign because that's used for something else that we're going to talk about later. And for the arithmetic operators as well, use the double equal, and any other relation operators are also vectorized. To check for any inequality, you can use the not equal operator, which is exclamation point equals, and then there's greater or less, which is the same thing. With the greater or less sign, you go greater equals or less equals. So we're going to go over a few examples. We're going to concatenate a function and check if each one of these is equal to 3. So we do concatenate 3, 4 minus 1, 1 plus 1 plus 1, and we go equals 3. And that's going to return 3 truths, so that's great. We're also going to do 1 to 3, and we're going to check if it's the same as 3 to 1. So we get true, false, and true. So that's working all fine. You can play around. We also do exponent of 1 to 5 less than 100. So that's true, 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 and then false. So, okay, you can just play around with that. There's also 1 to 5 squared, and we check if that's greater or equal to 16. So that's false, 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 true, and true. When we get to 4 and 5, it's obviously greater or equal to 16. And for the 1, 2, and 3, it is not. So you can... this only really works for integers. For non-integers, the double equal sign does not work that great because all the numbers that we've dealt with are just normal integers, so it's pretty easy. They're stored, they're easily stored in R. This is not really important. I'm just going to skip all this. However, if you want to compare more complicated numbers, for example, if you do square root of 2 squared and go equal 2, it'll give you a false, and that's because there's a rounding error. So that's fairly obvious, but it can be annoying and it can mess up your calculations. However, there's a function for that to check the equality of numbers. It provides a tolerance level. By default, it's 1.5 times 10 to the minus 8. So you can check that. And if we just check, the way it works is all dot equal and then parentheses in your calculation. So here we can do square root of 2 to the power of 2, comma 2, and it should return true. If the values are not the same, all dot equal will return the difference. So for example, if we do all dot equals square root of 2 to the power of 2 and 3, it'll give us the mean relative difference. And you can do the same for is true statement to check if they're equal or not. You can compare the double equal to compare different strings. So it is case sensitive as I show in this example. So we're just comparing, like we're typing a bunch of different cans and different letters and just checking if they're equal to can. And as you see, it gives us an accurate representation. You can do the same thing with ABCD and ABCD in non-capital letters. So that's pretty interesting stuff. I don't want to go too long into this video because you can really play around with it, and as you see, I am reading from the book right now. I don't know too much about this because, to be honest, I've never really had the need to use most of these because there's just so many different functions, and when you do need to use them, it's good to be able to look back. So I did make this video in case I'll ever need to look back or you need to look back, so I hope you appreciate it. And in the next video, we're going to be going into assigning variables, which is very important, and then we'll be jumping ahead into vectors, I believe. So logical vectors, so that's fairly interesting. So thanks for watching.